So hi and hello, welcome to our channel named Elko Exploration. My name is Sami and today we will going to continue about the merge sort. In the previous lecture I have shown you how the merge algorithm works. Now this will be our continuation of the merge sort. So here is the first question that we have given array of size 50 and we have to sort it using bubble sort. Now as we know that the time complexity for bubble sort is order of n square. Okay, now there are three cases that I would like to explain. Now the first case is, since we are given an array of size 50, we have to sort it. Now we are using here the bubble sort, so the number of comparison will be 50 whole square, that will be 2500. So to sort an array of size 50, the number of comparison are 2500. Now the second case is, here the size of an array is 50 and we are actually dividing into two halves. 25, number of elements here will be 25 and here also 25. And we have to sort this first and this first, and then we have to merge it using merge algorithm. Now to sort this array, it will be 25 square, and again to sort this whole array, it will be again 25 square. Now we have to merge it into, now if we calculate this, it will be 1300 comparisons. So we can see that if we divide an array into two halves, the number of comparison reduces significantly. Now let's generalize this. If we divide the whole array into two sub-array, then it will be n by 2 whole square for sorting the first half, and n by 2 whole square for sorting the second half, and then we have to merge this array using merge algo, that will be n. Okay, now let's see this third case. Now similarly it will be 50 elements. Now we have to divide into two halves, that will be 25 and 25. Again we are dividing into two halves, let's say it will be 12 and 13. Again divide into two halves, 12 and 13. Now we have to sort this first, so it will be 12 square. Then we have to sort this, that will be 13 square. Again we have to sort this array, that will be 12 square, and again this array, that will be 13 square. Now we have to merge this, so it will be 12 plus 13, that will be 25. So 25 plus, similarly here also we have to merge it, so the time will be 25. Now we have to merge these two array, so here the number of element will be 50. That will be in a sorted manner because we are sorting this array and this array, and we are merging it, so the resultant will be in a sorted manner. Similarly sort this array and this array and merge it, so this array should also be in a sorted manner. Now these two array are in sorted order. Now we have to merge it, so the resultant array will also be in a sorted manner, so it will be 50. Now if you calculate it, it will be, the number of comparisons will be 725. Let's generalize this. Firstly we are sorting this, so dividing this in first half, then again dividing it, therefore n by 4 whole square plus here this also, that will be n by 4 whole square plus sort this, that will be n by 4 only whole square, and again n by 4 whole square. Now we have to merge these two, so it will be n by 2. Again we have to merge these two, that will be n by 2, and again we have to merge these two, that will be n. So by observing this behavior, we design the merge sort in this manner, that we will divide it first until the number of element in the array will be 1 only, and after that we will start merging it using the merge algorithm. Let's take this example, that let's say the array where the starting index is 0 and the ending index is 7. So here the number of elements are 8. 0 to 7. Now we are dividing it. So to calculate the mid, it will be 0 plus 7 divided by 2. That will be, here the mid will be 3. Now a of 0 to 3, and this array will be a of 4 to 7. Again we will divide it. So here the mid will be 0 plus 3 divided by 2, that will be 1. So a of 0 to 1 and a of 2 to 3. Again we will divide it. So mid will be now 0. So a of 0 to 0 and a of 1 to 1. Now this array contains only a single element, so we don't have to go further. Similarly here also, a of 2 to 2 and a of 3 to 3. Now here the mid will be actually 2. Again we will divide this also. It will be a of 4 to, so here the mid will be 4 plus 7 divided by 2, that will be 5. So 4 to 5, and a of 6 to 7. Again a of 4 to 4 and a of 5 to 5. This also a of 6 to 6 and a of 7 to 7. After dividing till the array contains only single element, we will start merging it using the merge algorithm. Let's take this example and actually sort it. So here the mid will be 0 plus 6 divided by 2, that will be 3. So from 0 to 6, 0 to 3, divide it, and from 4 to 6, divide it. Now this array contains 70, 15, 100 and 80. Let me give the indexes 0, 1, 2 and 3. Again we will divide it. 0 plus 3 divided by 2, that will be 1. So from 0 to 1, the first array, and from 2 to 3, that will be second array. So here 70, 15 and here 100 and 80. Now again divide it. If you calculate the mid, it will be 0. So 70, 15. Here also we will calculate the mid, that will be 2. So from 2 to 2 and 3 to 3. So 100 and 80. Let's divide this array also. 200, 3 and 97. 4, 5 and 6. If we calculate the mid, it will be 5. So from 4 to 5, first array, and from 6 to 6, second array. Now again 200 and 5. Indexes will be 4 and 5. This will be 6. That will be 97. Now this array contains only single element, so we don't have to go further. Let's come here. So calculate the mid. 4 plus 5 divided by 2, that will be 4 only. So from 4 to 4 and 5 to 5. So let put here 200 and 5. Now the dividing portion is completed. Now what we'll actually do, we will start merging it. I hope you know how the merge algorithm works. Let's put P1 here and P2 here. Okay, now this will be our A1, let's say array 1 and array 2. Now we will check A of P1 is less than A of P2. Since it is not, that means A of P2 is smaller. So we will put A of P2 here 15 and we will increment the pointer of P2, right? So it will be out of bound. So what we will do, we will copy all the remaining element of A1 from P1 till the last index. Since it contains only single element, so we will put 70 here. Now we will merge these two arrays, A1 and A2. Again, P1 will be here and P2 here. Again, we will compare if A1 of P1 is less than or equal to A2 of P2. Since it is not, that means A2 of P2 is smaller. So we will put 80 here and we will simply increment P2. Now P2 is out of bound, so we will copy all the element of A1 from P1 till the last index. So put 100 here and that's it. Now we will merge these two arrays first. Okay, this will be our A1 and this array will be our A2. P1 will be at start of A1 and P2 will be at start of A2. Now we will do comparison. Is A1 of P1 is less than A2 of P2? Yes, it is. So we will copy and we will increment P1. Now again there will be a comparison. Whether A1 of P1 is less than A2 of P2? Yes, it is. So we will put 70 here and we will increment the P1. Now we can see that P1 is out of bound. So what we will do, we will copy all the remaining elements of A2 from P2 till the last index. So copy 80 and 100. Okay, now this is also in a sorted manner. Now we will compare these two arrays. Okay, so this will be our array 1 and this will be our array 2. P1 will be this and P2 will be this. Now we will check whether A1 of P1 is less than or equals to A2 of P2. Since it is not, so we will increment P2. Actually first we will copy A2 of P2 and we will increment it. Now we can see that P2, now we will copy 200 here. Now we have to merge these two arrays, this one and this one. This will be our A1 and this will be our A2. P1 will be this and P2 will be this. Now we will check whether A1 of P1 is less than A2 of P2. Yes, it is. So we will copy 5 here and we will simply increment P1. Again we will check A1 of P1 is less than equals to A2 of P2. It's not. So we will copy 97 here and increment the P2. Now we can see that P2 is out of bound. So we will simply put all the remaining element of A1 from P1 till last index. Now we can see that this array is also sorted and this array is also sorted. Now we just have to merge it again, P1 and P2. This will be A1 and A2. Now let's do the comparison. Is A of P1 is less than A2 of P2? It's not. So copy 5 here and increment P2. Again, A1 of P1 is less than A2 of P2. Yes, it is. So copy 50 and increment P1. Again, A1 of P1 is less than A2 of P2. Yes, it is. So put 70 year and increment P1. Again, A1 of P1 is less than A2 of P2. Yes, it is. So put 80 here and increment P1. Again, A1 of P1 is less than A2 of P2. No, it's not. So put 97 here and increment P2. Again, is A1 of P1 is less than A2 of P2? Yes, it is. So put 100 here and increment P1. Now we can see that A1 is out of bound. So we will put the remaining element of A1 from P2 till last index. So 200, and that's it. And we can see that the resultant array is in a sorted order. And in this way actually the merge sort will happen. Let's see the pseudocode. I have named the function as merge sort, and we are actually passing the array A, the start index and the end index, and we will see whether start is equals to end or not. If it is, then we will simply return nothing. This is due to when in an array it contains only single element. Now if this is not the case, then we will calculate the mid, and after that we will call the merge sort again, passing an array start index and the mid index and the remaining element from mid plus 1 till end, and will merge it. Let's find the time complexity here. This will be our small case that will take constant amount of time. This is our divide. This will also take constant amount of time. This is our conquer. That will take 2 into t of n by 2. Let's say this function takes t of n time. Now this will be our combine. That will take n time, because we have seen it. Why n? Because let's say the number of elements are n, then we are dividing it n by 2 and n by 2, right? Now again we have merging it. That will be n plus n by 2, sorry, n by 2 plus n by 2, that will be n. So due to this it will be n. Now let's find the recurrence relation. T of n is equals to 2t n by 2 plus n when the number of elements are greater than 1, or else order of 1 if the number of elements is equals to 1. Now this is nothing but cost for combine. Only at first level. Okay, so what will be the time complexity? It will be 2t n by 2 plus n. Now we have to calculate. We can calculate in many ways, but here I am going to calculate using the master theorem. Here a is 2, b is 2, and f of n is n. So n raised to log a base p, that is 2 and 2, and here it is n. So if we calculate this, it will be n. This one and this one are same, so we can see that it is n into log n. So the time complexity for merge sort is nothing but n log n. Now we have seen it previously that the time complexity for bubble sort is order of n square, but the time complexity for merge sort is order of n log n, which is quite optimized. So this is the efficient sorting algorithm. Now in the next lecture I'll show you how the quick sort works. So thank you.